So welcome, this is a video for IBDP AAHL TC2 paper 2 from May 2022. Question number 10, part ABC was done in the previous part. Now we are doing it on part D. So we'll continue with part D and question number 11 in this video. So part D, it says from 0 to 9, find the total amount of time when the rate of growth of plant B is greater than rate of growth of plant A. So for that, what am I supposed to do? I am supposed to find the derivatives of both plant A's growth and plant B's growth. So over there I am going to write HA prime T and HB prime T, both the derivatives for both the functions. I'm going to draw it out and try to solve them and equate them. We can see that they are intersecting that from GDC. If you draw the graphs for both the curves of the derivative curves, we can see that they intersect at these points 2.23598. This can also be written as 4 pi by 3 minus 3, or it can also be written as 5 pi by 3 minus 3. Some calculators gives you the exact value, some calculators gives you the the 6 significant figures. So apart from this, they also do intersect at 4.33038 and 5.37758, and one more interval will be 7.4797, 8.51917, and so on. So this value is going to be 7 pi by 3 minus 3, 8 pi by 3 minus 3. And this is going to be 10 pi by 3 minus 3 and 11 pi by 3 minus 3. So I bring this one over here. So these are the points of intersection for these two derivative graphs. Now in between these two intervals, these three intervals, the derivative of h prime b is greater than the h of h prime a. So what am I going to do? I'm going to find the difference. So the difference is going to be, if I'm going to subtract it out, it becomes 4 pi by 3 5 pi by 3 minus 3 minus 4 pi by 3 minus 3. So it's going to be pi by 3. So that's going to be the difference. Pi by 3 is going to be the difference. So if I bring this down and make space for writing, so the same is the case for the second interval also. It's going to be 8 pi upon 3 minus 3 minus 7 pi upon 3 minus 3, which gives me again pi upon 3. For the third interval also it is 11 pi upon 3 minus 3 minus 10 pi upon 3 minus 3. This is also pi upon 3, and we can see that this difference pi upon 3 is 3 times. So 3 times pi upon 3 going to be pi. So for pi weeks, don't forget to write the units. Pi weeks, the difference will be, according to the question, pi weeks, the rate of growth of plant B is greater than that of plant A for pi weeks, total amount of time. So total amount of time is going to be pi weeks. So this part was not done in the previous video. Now we completed question number 10. Going to question number 11. Two aeroplanes A and B have a position vectors. Then what is he asking? Find the tree figure bearing on which plane B is traveling. So direction will give us the bearing. Bearing is always tan inverse of y upon x. So we get it out, tan inverse of 1 upon 2, which is going to be 27 degrees, but it is with the x-axis. So 27 degrees we got with the x-axis, but the bearing is always with the y-axis. Over here, if I draw the diagram, we have calculated this value was 2 and this value was 4. This angle was 27 degrees, but the bearing is calculated from the y-axis in the clockwise direction. So it should be 90 minus 27, which is 63. Again, bearing should be written in 3 significant figures. So 063 is going to be the bearing. Show that aeroplane A travels at a greater speed as aeroplane B. So speed, the direction gives you the speed. So direction of A. So absolute value of the direction is going to be the speed. So BA's absolute value direction will be square root of -6 whole square plus 2 square plus 4 square, which is going to be square root 56. Whereas for B's direction's absolute value is going to be 1 square plus 0 square plus 12 square. We take the absolute value for the directions, not the points. Over here I taken the points, so again I take it out for the directions, which is 4 square plus 2 square plus 2 square. So it's going to be square root of 16 plus 4 plus 4, which is 24. So we can clearly see that absolute value of a BA's direction is greater than absolute value of B's direction. Therefore, A travels at a greater speed than B. Next, find the acute angle. The question is the acute angle. So obviously remember the question is asked about acute angle, so never leave the answer in obtuse. Between the two planes of lines of flight, give your answer in degrees. Again, angle is always between the directions. So direction vectors of those two are given. So I'm going to find it out cos theta. So I start in a new page, then cos theta. So cos theta equals to A dot B. So dot product of the both the directions, 2 times 2 plus 4 times -2 divided by square root of -6 square plus 2 square plus 2 square times 4 square plus 2 square plus -2 square. As such is asking acute angle, keep just absolute value. So automatically you will be getting it out acute angle. So becomes cos theta equals to, this becomes negative 0.7637, but because of absolute value it becomes positive 0.7637. So theta equals to cos inverse. If at all acute angle is not asked, you no need to use absolute value. So cos inverse of 0.7637, which gives me 40.2 degrees. That's going to be the answer. Next, two airplanes lines flight cross at a point P. Find the coordinates. Means, what am I going to do? I'm going to find any point on A and any point on B and equate them. So I'm going to find it out. Any point on A and any point on B. So any point on A will be 19 minus 6t1, comma, -1 plus 2t1, comma, 1 plus 4t1. Similarly, I'm going to find any point on B. It is 1 plus 4t2 maybe and 2t2 and 12 minus 2t2. Now equating both, equating the two coordinates x and y coordinates and substituting that value in the z coordinate. Then if at all it is satisfies, then they meet. If that doesn't satisfy, they don't meet. So what am I going to do? I'm going to take simultaneous equations for the first x and y coordinates equals to -1 plus equals to 1 plus 4t2. So what is the equation I get it out? I get as 6t1 plus 4t2 equals to 18. That is the first equation. By equating the y coordinates, 2t1 equals to 2t2. So it implies 2t1 minus 2t2 equals to 1. Solve these two by GDC simultaneous equations. We will be getting t1 equals to 2 and t2 equals to 3 upon 2. Then upon solving it out, substitute this values in the third coordinate. Third coordinates are nothing but what? 1 plus 4t1 should be equals to 12 minus 2t2. If it satisfies, they intersect. 4 times 2 should be equals to 12 minus 2 times 3 upon 2. 9 equals to 9. So they do intersect. And what is the point of intersection? Now substitute either t1 or t2 in one of the point. So I substitute t1 in any point on A. Any point on A was 19 minus 6t1, comma, minus 1 plus 2t1, comma, 1 plus 4t1. Substitute t1 equals to 2. So 19 minus 12 minus 1 plus 4, comma, 1 plus 8. So it's going to be 7, 3, 9. This is the point of intersection P. Then determine the length of the time between the first aeroplane arriving at P and the second airplane arriving at P. So first airplane was arriving at T1, which was 2, and second airplane was arriving at 3 upon 2. So what is the difference? T1 minus T2. So 2 minus 3 upon 2, which is 0.5 minutes. The difference is 0.5 minutes. So first one will take 2 minutes to arrive at P. The second airplane takes 3 upon 2 minutes to arrive at P. So the difference in the time is 0.5 minutes. And finally, what is being asked? The distance between the airplanes should be minimum. So what am I going to do again? When I have found it at 2 points, any points on the plane of the plane's path, I am going to subtract them and get the distance between them. So first of all, I copied on this any points over here. So distance between them. Distance equals to dt equals to subtract. It becomes 19 minus 6t minus 1 minus 4t. So it, comma, minus 1 plus 2t minus 2t. You should be taking at the same time. So that's why no t1, t2. 4t minus 12 minus of minus plus 2t. So it becomes 18 minus 10t, then minus 1, comma, then minus 11 plus 60. Now the distance is going to be absolute value. 18 minus 10t whole square plus 1 square plus minus 11 plus 60 whole square. This has to be minimum. There is option you can do the differentiation and find the minimum, or else directly plot this one on the graph and find the maximum value. So what am I going to do? I'm going to find the derivative of this. So that is one of the method of solving it out. So let me expand this one now. It becomes square root of 18 square. 18 square is 324 minus 2 times 18 times 10 is 360. I'm doing without calculator. Plus 100t square plus 1 plus 11 square 121. Then minus 2 times 22 times 6 is 132t plus 36t square. So I'm going to get 136t square. Then this 2 is minus 492t, and 122 plus 324 gives me 446. Now find the derivative of this and equate to 0. So when I find the derivative of this and equate to 0, it becomes, only you not find the derivative with the square root, just only without square root you can find it out. It is 272t minus 492 equals to 0. So this gives me t equals to 492 divided by 272, which gives me 1.8088. So dt will be maximum at or minimum over at this time. So find it out the distance. Now substitute the t in the equation. So dt is going to be square root of 18 minus 10 times 1.8088 whole square plus 1 square plus minus 11 plus 6 times 1.8088 whole square. Simplify that. I'm directly writing the answer 1.01459. That's going to be the minimum distance.